10% times, or the significance times negative of that. Yes, I'm not done yet. Otherwise, if it's positive, otherwise, if it's greater or equal to that times that. Okay. So we know that it is pretty high number, so I don't have to worry about it. If you want, you could also apply a significance test on the IRR. Let me see. Let's make that bold. If IRR is valid, maybe you can do a plus or minus some margin of error. That's another way of kind of looking at it. I'm not going to, but you could. All right, we have about how much? 20 minutes or so. There are two more things that I want to talk about in this chapter. One is the issue of um, decision about assets with different useful lives. Suppose I have a choice to make. Whatever I'm doing doesn't matter. I have a 10-year project and I need a certain kind of machine, and I have three choices. The first choice, or let's say I have a 12-year project. The first choice is to buy a machine that's cheap, but I'm going to have to replace it every 3 years. And the second choice is to buy a machine, but I have to replace it only once during the life of the project, every 6 years. And the third choice is the most expensive machine. It's going to last me to whole 12 years. Well, since these have unequal lives, which one of these I need to use? Well, there comes the concept of equivalent annual cost. It's EAC. That's basically EAC is the equal amount of payments or installments you could make to buy the asset over its useful life that has the same present value as the cost of buying the assets outright right now. So if I have an asset that costs $3 million right now, I can either pay $3 million or I can say, how about if I made three installments? What would be those installments? This is similar to a mortgage or a car loan. It's basically payment on an annuity. Turns out EAC is equal to payments on an annuity of n years with discount rate of R and present value of cost. There's an ugly little formula. I'm going to write it just to piss you guys off, even though we're not going to use it. We could either do that or use the Excel formula. PMT, R, and negative cost. Anytime you want a PM payment on a annuity, you can use that to calculate it. You don't have to use a template. So if I did this, let's see, let's do a separate. So I have choices, life, cost, um, so 3 years, I don't know, let's go 10 million. Six, 12, so these are your choices. You have to pick one of the machines, cheap one, medium, or expensive. Well, expensive is really expensive, but I'm going to have to replace that 3-year one 4 times, right? What you need to do is calculate the EAC, which is going to be a red cell, dollar format, PMT, my discount rate, life of the project, and negative of the cost of the project. So I could either buy I could either pay $10 million now or make annual payments of 4.379. Of course, those are my alternatives. So which one of these assets would be the cheapest in terms of equivalent annual cost? Well, it looks like the 12-year machine is the best because it only requires me to make 3,689 payments over 12 years instead of 12 payments of 4.379. So that's where equivalent annual cost comes in. Now, there's one more issue that's before we go into chapter 7 next week. Chapter 7 is kind of more about thinking about real options. How do we account for contingencies? I think the project is going to make me $105 million a year, but that's an estimate. Next year, I could find out that 105 was too much. I could only get 90. At that time, I'm going to have to make a decision. Okay. Well, in fact, if I go back to this, let's see. Or it's going to cost even more, something like that.